I'm going ahead, Ganesh, yeah? Is it okay? That's not according to the script, but I'm good with that. All right. We went through this this morning, this earlier today already, so I'm not going to repeat the overview of the project. But again, as I said, many of you will visit the plant that's close to my heart because it's the first coal project that I've built. I'm both proud of it and not proud of it. I'm confused, I guess. But it is a very beautifully maintained plant. You'll see tomorrow. Every time I go to the site, I think twice, actually, whether to do this or not. But I have to remind myself of the greater good. So, and a gathering like this makes me stay committed to this course, no matter how challenging, difficult, and pristine the plant is. I promise you, Ambassador Ravi, that you will fall in love with the plant after this and then be confused, but we can discuss over drinks to push through with this nevertheless. Anyway, some highlights here. The plant produces steady baseload power, 1.8 billion kilowatt hours per year. Okay, steady, reliable baseload. And ASEN remains as the off-taker, even if we sold it already, divested. To enable that ETM deal, we had to be the off-taker until 2040. Otherwise, there's no deal, okay? So, but it's allowing us to serve part of our transition plan because we cannot leapfrog overnight and just switch off the coal plant. This plays a very critical role in our overall portfolio. It is very cheap today. It's about 9 US cents, less than 5 pesos per kilowatt hour. That includes the fuel cost and the operations and maintenance and the capex recovery cost as well. Coal is still one of the cheapest baseload reliable technologies, like it or not, at least in the Philippines, right? It has about 200 workers plus some temporary workers. Probably the total, if you include temporary workers, about 500-600 people altogether. The emissions, though, is quite high. It's 1.9 million tons per year on average. Not quite the 1.8 million on Shari. It's closer to 1.9 than 1.8 million. And again, we started operations in 2015 for Unit 1 and for Unit 2, 2016. So we're committed to shut it down, retire it by 2040 or after 25 years of operations. But we are hoping to accelerate that with the use of transition credits and effect a just transition as well as replace it in a responsible manner with a clean energy replacement. So how does the clean energy replacement look like? Again, this is our latest thinking. It can evolve over time, but this is our best thinking right now. We are going to replace a 246 megawatt of 2 units. That's 2 units of SLTech, Unit 1 and Unit 2. So we could replace it with 2 units also, if you will, of clean energy replacement. So Unit 1 will be replaced by 200 megawatt solar plus battery storage, and then multiply that by 2, so it's 2 times 200 megawatts, so to replace both units. And by the way, based on the project methodology, Vera methodology, or carbon principles, core carbon principles, the retirement of a coal plant, can be done on a per unit basis. It doesn't have to be all or nothing on a whole plant. So we can do this in a phased manner. So 2 by 200 megawatts. What does that actually mean? So so this is 400 megawatts. You might wonder why 400, not 246. Well, the reason is, yes, we can replace it on a literally 100% like-for-like basis, which is 24/7. Then we would only need 246 megawatts, or 2 by 123. But that will be very expensive, right? So, and frankly speaking, based on what the system needs today, the system needs more what we call mid-merit, which is the 12-hour supply of power from 8 a.m. to 9 p.m. or 8 a.m. to 10 p.m. is the most critical because that's when the peak demand of the grid is, not at 3 a.m. Why would we produce the expensive solar battery at 3 a.m. if the grid demand at that time is very low? So there is a pragmatic, practical, grid bespoke element to this technical solution. but battery needs to be incorporated. That's non-negotiable for us and arguably for the Philippine government, right? We need to be responsible. So this system will basically consist of 1,400 megawatts or 700 megawatts of solar panels. That's about 700 hectares of land each, right? It's 1 megawatt, 1 hectare. So 1,400 if you look at both units. And then we will need 4 hours of battery storage. So 400 megawatts times 4 hours, that's what the 1,600 megawatt hours means. It's estimated to produce more than 1,800 gigawatt hours or 1.8 billion kilowatt hours. Basically, on year 1, actually, this is estimated to produce 2 billion kilowatt hours per year. We're purposely oversizing the plant because solar plants degrade by about 0.5% per year. And we want to make sure that we are not falling short of the replacement energy. That's why we are being on the conservative side and overproducing from an output perspective. And as we mentioned, it's 1-to-1 pairing. The estimated project cost, although we hope to improve on this, is about $1.5 billion US. The coal plant, when we built it 15 years ago, was, 10 years ago, was worth $500 million. But we have to pay for the coal, for the fuel. Here, fuel is free because the sun is free, fortunately. But the capex is much higher. But the level, what we call the levelized cost of electricity is higher than coal plant today. That's about 13 to 15 US cents per kilowatt hour. So there is a gap. So that gap is about 30 to 35%. This is 30 to 35% more expensive than what we are paying SLTech for the coal plant output. We need to cover that gap of 30 to 35%. You do the simple math here, 30 to 35% of $1.5 billion. I'm just oversimplifying with a ratio and proportion, but that is not too wrong. That's about $500 million. Lower gap if we're able to lower this because of lower battery prices and so forth, right? Or optimization for the renewable configuration. So orders of magnitude to keep customers, investors, et cetera, whole on the clean energy replacement, we need roughly $500, hopefully less, million of subsidy so that the pricing will be at least the same. Now, we also, and I'll get back to that later. So basically, we, on the left side here, you will see that the crediting period, and we can get to the transition financing, the securitization that was discussed earlier by Wiseng. But the crediting period is going to be 2031 to 2040, and therefore, the carbon credit revenues will be generated in the future. But as you can imagine, we will need the subsidy, the funding, upfront. We will have to start building the clean energy replacement in 2028 if we are to complete the plant by 2030. While Vera methodology allows us to replace just 10% on year 1 and 40% by year 10, in this case, we want to replace 100% on year 1, on day 1. In fact, on day negative 180, because we want this clean energy replacement to be operating well before, 6 months before the coal plant is shut down. So basically, there is a mismatch of timing of cash flows, and Ganesh and I, hopefully, we can discuss the securitization of those cash flows as well. Anyway, I'm not going to talk about the key off-takers. I'll leave that to Nat in a bit in the next session. But the uses of the transition credit proceeds, I think I already double-clicked on point number 3, which is a CR subsidy, and that is why this is taking the lion's share, 50 to 60%. The next large use of proceeds is number 1, which I discussed during the panel. We have to keep everyone whole. And orders of magnitude, that's probably in the sub $300 million range. The coal plant makes an EBITDA of about $60+ million per year. So if you did your financial analysis here, you're going to come up with a number that's on a net present value somewhere in the $250, $300 million, depending on your discount rates and so forth. So plus the other, 2%, as Frederick mentioned, of the proceeds to ensure a just transition for the community and so forth, we would then come up with these other sources or uses of funding, which comes up to about 50, 40, 10, roughly, split of use of proceeds. Now, again, these numbers are a work in progress. We're trying to sharpen the numbers so that the more savings we get, and again, financing will be a big part of this. The lower cost financing there is, the lower the subsidy will be, because we want as low a carbon price as possible to make it more accessible to more off-takers. But we cannot sacrifice this, the high quality nature of this transition initiative. So let me leave it at this and invite Ganesh over to speak about other dynamics of transition financing.